Hi everyone, today we're talking about scatterplots and how to construct them. You do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important information, rewind to view information again, and fast forward if you think you got it. But don't fast forward so much that you miss out on something important. So let's start off with what a scatterplot even is. A scatterplot is a type of diagram that plots the values for two different variables from a data set. It's very important that there's two different variables. And since there's two different variables that you're plotting, you're basically using the coordinate plane to plot. So you have one number on the bottom and one number on the left-hand side axis that you're joining together to make a dot. So at the end it looks like a bunch of dots that are scattered around. And a scatter plot is used to show possible correlation or relationships between the two variables. So for instance, in this example, we have different people and we've recorded their height and their weight. And each of these dots is going to represent one person. So for instance, Sean Sean is 185 centimeters tall. So this is his dot here. 185 centimeters is between 184 and 186. And then we stop that dot at 83 kilograms because that's his weight. So again, each of these represents a person. This one right here with the dotted lines is somebody that is 186 centimeters tall and weighs 84 kilograms. 186 and 84. So this is Daniel. So all these dots represent people, and then they're going to look like a bunch of scattered dots. So that each dot shows us two pieces of information for that person. And then we can see if there's a relationship between these people's height and their weight. So it looks like there kind of is a relationship because it's going kind of in a straight line upwards. So it looks like the taller you are, the heavier you probably are as well, which makes sense. There's more weight to you. Be sure to have that copied down, especially the definition, before you move on. All right, so something I do have to caution you about though is that correlation, the relationship between the two variables, doesn't necessarily mean causation. So just because two things are related to each other, two variables have a relationship or a correlation, doesn't mean that one causes the other to change. In this case, somebody's height doesn't necessarily cause them to weigh more, because you could have a really tall person that maybe doesn't weigh as much because they have less mass. So it doesn't necessarily mean a cause and effect every time. So like we said, just because two variables are correlated doesn't mean that one caused the other. The correlation could be explained by a third variable. So the example that I like to give is this one right here. I have a scatter plot that shows the number of firefighters at different fires and then the amount of damage to that property. So if we assumed causation, that one caused the other, we would think that more firefighters on the scene would cause more property damage. But that doesn't make any sense, right? We're not going to say, oh, don't bring more fires to this fire. You know, like we don't need any more fires because studies have shown that the more firefighters we bring over, the more damage it's going to cause. That's not necessarily the case. If that were the case, then we would bring over 0 firefighters and nothing would be damaged. So that doesn't make sense. There could be a third variable. Think to yourself what that third variable in this scenario might be. What else could be causing both the number of firefighters to go up and the amount of property damage to go up? You should have probably said something like this, that the third variable could be the fire size. More firefighters could have been called to put out a bigger fire, A bigger fire could also end up possibly causing more property damage. So the third variable that's causing both of these to go up at the same time is the fire's size. It's not that more firefighters at the scene will create more or cause more property damage. They just happen to both be increasing at the same time because of a third variable, the fire's size, or just the fire's intensity. So again, correlation, just because two variables are related doesn't mean that one caused the other. Be sure to put that in your notes. Okay, and the last thing that we have to talk about is just convention. So a good scatter plot is going to use a reasonable scale on both axes. So like for this number of firefighters, we're not going to go by ones because we have to go all the way up to 40. And for the property damage, we're not going to go up by $10 because houses or buildings are going to have way more property damage. So that's what we mean by a reasonable scale on both axes, this axis and that axis. The other thing we have to keep in mind is that the explanatory variable, so the possible cause, doesn't always mean that it's the cause, but something that could be the cause of the other one changing, when we talk about dependent independent variables, is put on the x-axis. What we think could be a cause would be put on the x-axis. So like here, we wouldn't put property damage on the x-axis and number of firefighters on the y-axis, because in no way, shape, or form would property damage cause there to be more firefighters coming. We don't know about how much is going to be damaged until after the fire is put out. So whatever could possibly be explanatory or the cause, a possible cause, is always put on the bottom of the x-axis. So be sure to put that in your notes as well, and we're going to go over some examples. All right, so let's first look at how to construct scatter plots. On Khan Academy, you can click to add points and you will be given data on a chart. So in this example, it says Garrett collected data about exams in each of his classes from the previous year. Plot the data in a scatter plot. So here we have the period for the x-axis and the average score for the y-axis. Notice how they put the period on the x-axis because that could explain any changes in average score. It could be that maybe one period did better than the other or worse than the other. Maybe they got slightly different instruction, but average score wouldn't cause the period, the class period, to change. Class period or subject isn't going to change the average score. Okay, so let's take a look at this information. So we have the average score of 60 for first period, which happens to be a history class. First period, 60. Arts is 6th period, and that's a 90. The other thing they could think about is maybe like the time of day that'll affect the scores. Maybe you're sleepier later on. Okay, second period is English, and that's a 55. Or maybe people like English more or don't like English as much. So 2 matches up a 55 for the 255 for English. Computer science is 7th period. The average was a 95. Let's see. Third period math, the average was a 60. Fourth period biology, the average was an 80. Okay, it does look like the later periods tended to have higher scores. Maybe people are sleepy in the morning too. Okay. All right, here is a problem asking you to make appropriate scatter plots. It says a group of meteorologists want to investigate if average low temperature is a function of latitude. So this is a function. They want to know if average low temperature is caused by the latitude. They collected data in the table below for different cities, and they want to know that which of the displays, graph A, B, C, or D, is the best. All 4 of them display the data correctly. They want to know which one is the best. So pause your video and see which one you would choose. Okay, the piece of information I really need to hone in on is this right here. I want to know if average low temperature is a function of latitude. So they want to know if latitude causes the low temperature to change. So that means if latitude is supposed to explain that change, latitude should be on the x-axis. Latitude should be down here. So we're really choosing between A and C. A and C. Because latitude, they said, they want to know if it causes low temperature to change. So now we're just choosing between scales. Do we want it more spread out, or do we want it more squished together? Which one is probably better? So you would normally think that C is better. A lot of times people draw graphs like C because they want to make sure they have all the numbers in, and they also have a lot of space. So a lot of people create graphs like this. You probably have created graphs like this in the past where you think, oh my gosh, I'm given this huge piece of paper, but I don't know, I feel bad not filling up the entire space. Resist that urge, okay? What you should be doing when you get your information and you're creating a scatter plot is to look at your range. What's the lowest number and what's the highest number? For low temperature, it ranges from 1 to 20. So it should fit that. And then for latitude, your lowest number is about 13, and your highest is about 48. 13, 48. That extra space is not going to help you with scatter plots and to see patterns because it's going to squish everybody together. So remember, if we want to see if there's a relationship, we want to see if this kind of line that it's making, these points, this pattern, is going up or going down. The more squished you get, the harder it is to see the relationship. It just becomes just like a mess of dots. But when they are spread out a little bit more, you can see that it's kind of going downwards here. The higher the latitude is, the lower the low temperature is. But if they're all squished together like a ball, it's harder to see that. So the answer here should be A. Okay, so again, we chose A because the latitude, the explanatory variable, is on the x-axis, and then it is spread out enough that we can kind of see a pattern. All right? Let me know if you have any questions as you work on these problems. Keep those 2 things in mind for the appropriate scatter plots, and I'll see you in class.